This time I will discuss one-way slab design. One-way slab. Now, what is one-way slab? Say there is a slab. If one side is A is other, not A, say it is B, this side is A. If the ratio B by A is equal or greater than 2, it is called one-way slab. Again, if my slab dimension is such that one side is twice or larger than other side, then the load goes this way. The load distribution goes this way. That means 50% load goes that way, other 50% load goes that way. For this kind of slab, we call it one-way slab. The load distribution is one way. Just to clarify, if there is a say square type slab, load goes two way. So this load goes that way, this load goes this way, this load this way, this load goes to this way. But if my slab is one side is so long, then load goes one way. So today we will learn one-way slab design. One-way slab. So in fact, in this video lecture, I will not design any one-way slab. I will discuss some knowledge on one-way slab. So this is a one-way slab. This side is longer, this side shorter. So this is my span L. Now, how to design one-way slab? Very simple. As the load is one way, load goes only this way. What we do? We assume a 1 feet strip, 12 inch or 1 feet strip. So we assume this. Then we draw it as a beam. Beam, and the cross section width is 12 inch, height we do not know. Yes, so this is the main concept of one-way slab. It is actually a beam. If one side is so large that load goes only one way, what we do, we take a 1 feet strip and design as a beam. Now whatever my reinforcement in this beam, we keep on doing this, doing this. So that is the concept of one-way slab. So one-way slab is nothing but a simple rectangular beam. Okay, that is the first concept about one-way slab. Something else. What is something else? In one-way slab, ace mean is a concern item. The ACI code recommended some minimum thickness for slab so that it doesn't vibrate so much. But again, ACE mean listed in your book table 4-1, they gave us some recommendation. For example, if it is simply supported, solid, then ACE mean is L/20. Now again, this requirement is just a vibration requirement. It is not structural. That means if you do not provide it, your slab will not fail. It will just vibrate. When somebody upstairs will walk, you will hear the vibration or the noises. That is something to discuss. Yes, this is a concern issue for slab. For beam, typical the thickness or depth is so high that we do not need to concern about it. Okay, concern number 2. The load on a slab is very small because there are so many beams, and inside beam the slab length is not so huge, so load on slab is very small. So minimum reinforcement is a concern. So rho mean, yes, rho mean for flexure. So rho mean for flexure is a concern. Most of the cases, the steel required may be less than the minimum recommended for flexure. So check it. Yes, whenever you calculate the reinforcement, make sure it is more than the minimum. That is number 2. Number 3, if I draw that slab again, so say this is my slab. So this way we will provide flexural reinforcement. flexural reinforcement. But that way there is no load, it is true, but that way it may contract or expand, contract or expand. So this way we need to provide temperature and shrinkage reinforcement. Temperature and shrinkage reinforcement. So this way will be our main reinforcement, that way will be our temperature and shrinkage reinforcement. Typically this reinforcement is less than the minimum of flexural. Now, how much? What is the temperature and shrinkage reinforcement? Rho T, I write this way, temperature and shrinkage. Rho T S is 0.0018 for 60 ksi still. The temperature shrinkage reinforcement ratio 0.0018 per 60 ksi. It is 0.002 for 40 and 50 ksi still. If your reinforcement is 40 or 50 ksi, then it is 0.002. Okay, so that is the temperature reinforcement. Something else also, the maximum spacing of reinforcement this way. The maximum spacing, this spacing can be 3 times H or 18 inch. The maximum reinforcement that way is 5 times H or 18 inch. That is something to remember. Anything else? Let me see your book. So I covered slab, I covered temperature and shrinkage reinforcement, 2 items more. If your slab thickness say 6 inch or less, round the slab thickness in 0.25 inch. It is not a requirement, but it's practical consideration. If it is more than 6 inch, round off to 0.5 inch. Okay, that is the other item. And the last item is clear cover. Say in your slab, the reinforcement is here, and in slab we do not use any tie. So what is the clear cover here? Clear cover, or simply we call cover. Cover is 0.75 inch. So cover is 0.75 inch, and from centroid of the bar to this, to the outside, maybe 1 inch or even less, sometimes maybe more. So roughly 1 inch. So if this is my beam, yes. Okay, let me show the profile. If this is the beam, my reinforcement here, from here to here is roughly 1 inch. Roughly 1 inch. How? Because my cover, clear cover is 0.75 inch. From center of the bar to some, so roughly 1 inch is a good approximation. So hopefully I discuss all the knowledge required for one-way slab design. In the next video, I will start designing a slab.